Well, in this section, we're going to study transformations of functions. Basically, that means if you know how to graph a nice set of functions, maybe from memory, and you come across something that looks similar but not quite the same, using transformations of functions might allow you to graph that new function without making a table of xy values and using that point plotting method. But first, we need to know certain functions. We have to memorize certain functions, the graphs of certain functions. So let's look at just a handful of some important functions. First, we'll do a constant function. Well, all that means is a horizontal line. That would be something like, y equals 2. I'll write it as f of x equals, I'll put c for a constant, where that's c on the y-axis. Okay, constant functions are easy. The identity function is also easy. If you haven't heard it referred to as the identity function, it's f of x equals x. Identity means you plug in a number and you get that same number out again. So all of the points on this line are like 0, 0, 1, 1, 2, 2, negative 10.1, comma, negative 10.1. And we all know that this looks like a 45-degree angle. It's the line that has a slope of 1 and goes through the origin. So that's the identity function. And then we've seen the absolute value function before. And notice I'm drawing these without using, the xy coordinate. I've got these memorized. That is the absolute value function. And then we'll do the square function, not the square root yet. We'll use the square function, which, let me write this in. F of x equals absolute value of x. Over here, this will be f of x equals x squared. So that gives us a graph that looks like this. Something like that. And then now we'll move to the square root function. Well, the square root function, actually we'll see later, if you were able to take half of this graph here of x squared, like take from here on the left half or the right half, pick it up and move it over here, it would look just like it. Just like this. That's f of x equals radical x. So obviously there's nothing on the left half because we can't plug negative numbers into this function. We can only plug 0 or positive numbers. So it looks like this. And then we've got two more to do. Let's do the cube function, which would be f of x equals x to the third, x cubed. Well, it actually looks similar to this, only a little steeper. But when you get to negatives, it goes down this way. So it'll look more like, it's quite a steep graph. That's pretty much what f of x equals x cubed looks like. And then when we get to the cube root function, f of x equals the cube root of x. It actually has exactly the same shape as this graph. If you could pick this up and maybe flip it around and move it sideways, we would get something like this. That is the graph of f of x equals x cubed. So these are some important functions that you do not have to memorize what these graphs look like, but it might save you some time in doing problems. Okay, so let's learn about our first transformation of functions. One of the things you can do is shift the function up or down, called a vertical shift. All right, so let's say f is a function, and let c be some positive number. Well, the graph of y equals f of x plus this constant is, and I'll worry about this one later, is the graph of y equals f of x, without that plus c, shifted c units vertically upward. If you're subtracting c, it would be shifted c units downward. Okay, so in this example, we're going to use the absolute value function. That's f of x. G of x is going to be the absolute value of x plus 2. Well, notice how this applies. Notice that it is definitely a vertical shift up, because this is the same as saying g of x is f of x plus 2, because f of x is this absolute value of x right here. So this would be like having the c value being a 2. Maybe I'll write g of x equals that. And then h of x would be equal to f of x minus 2. And because we're able to relate g and h to f, we can use transformations of functions. So let's do the absolute value function. That's f. And now we're going to go to g. G is the absolute value plus 2. So all that's doing is increasing the y value by 2. So we're making it, this function, 2 units higher. So we'll go 1, 2, and it's going to look like this. So that would be g, or g of x. And then for h of x, we're going to, our c would be a negative 2, or we're going down to, our c would be 2, but we're doing minus 2. So it's going to go here. That would be h. So very simple. So anytime you have a function, if you'd like the graph to be 10 units up, all you do is put a plus 10 at the end of the function. If you want it 10 units down, you just put a minus 10 at the end of the function.